There is one example asked for a 7 marks. Data is given. We have to first understand what is the data is given. An iron ring has a mean diameter of 40 cm and a cross sectional area of 5 cm square. It has 1200 tons of a coil and an air gap of 1.5 mm. Determine the current required in the coil to establish a flux of 0.5 milliweber in the air gap. If relative permeability of iron core is 800, we neglect the leakage and the fringing. So two things are neglected, leakage and fringing. Data is given. Few data are highlighted into the PPT. First is diameter is 40 cm, cross sectional area is 5 cm square, 1200 tons, air gap of 1.5 mm, and we have to determine the current required. So based on the data we will go through the example. So let's see in the projector. Data is mentioned here. See, this is one iron ring. Iron ring having some cross sectional area A. Air gap is L, represented by L, a length of air gap. Now diameter is 40 cm, cross sectional area is 5 cm square. Each and every data is needed to be converted into the meter. So we have write down here 5 into 10 raised to minus 4 meter square. N is equal to 1200 tons. LA, length of air gap is 1 mm. We can write down 0.1 centimeter. Flux, we require to produce a flux of 0.5 milliweber. It means milli is equal to 10 raised to minus 3 Weber, and relative permeability mu r is given 800. Now on the given data we have to find out how many current will be passed through the coil. So for first we have to find out the core length of the ring. So for iron ring, first we find out the mean length. How much mean length of the iron ring? Length of the iron ring equal to pi dm minus 0.1. See, the total mean length is given by pi into dm, that means core diameter, but there is a air gap of 0.1 centimeter. Here I have converted into the centimeter because dm is given into the centimeter, so I have converted my LA into the centimeter. So put the value pi into 40 centimeter minus 0.1. using multiplication, calculating, we get 125.5 centimeter. So it is a length of iron core. It is a mean length of iron core is 125.5 centimeter. If I am taking 2 point ahead, I get 1.255 meter length. It is a core length or mean length of iron core. Now we find out what is the reluctance of iron core. So find out the reluctance of iron ring. Find out the reluctance of iron ring. So as I is indicating the iron ring, Li upon mu 0 mu r into cross sectional area. So mean length we have find out into meter 1.255 meter, and as we know that the constant mu 0 is permeability of air is 4 pi into 10 raised to minus 7. Relative permeability mu r is given into the data. It is 800 into area, cross sectional area is 5 into 10 raised to minus 4 meter square. 5 centimeter square, if centimeter is converted into meter, we get 5 into 10 raised to minus 4. By solving all this term, we get the reluctance of iron core is 249.8 into 10 raised to 4 ampere turn per Weber. It is the reluctance of iron core. Now similarly we go and find out what is the reluctance of air gap. So that means that is a one type of resistance. We can say reluctance is a resistance for magnetic material. So we go and find out the reluctance for air gap. Reluctance for air gap. So simple equation, SA equal to LA mu 0 mu r A. Now see, here we have mu 0 into mu r. It is a relative permeability of air. It is a relative permeability of air. So relative permeability of air is always 1. So now put the value. Length is 1 mm. So 1 into 10 raised to minus 3. Mu 0 is 4 pi into 10 raised to minus 7. Again keep in mind mu r is relative permeability of air, because we find out for air, so its value is 1. That is not given into the data, so we have to remember about the value of mu r. And 5 into 10 raised to minus 4. Again by solving this we get SA equal to 159.2 into 10 raised to 4 ampere turn per Weber. So I get the SI, iron core reluctance, I get the air core reluctance. So total reluctance is given by S equal to SI plus SA. SI is 249.8 into 10 raised to 4 plus 159.8 into 10 raised to 4. Taking 10 raised to 4 as a common, so we get total reluctance is 409 into 10 raised to 4 ampere turn per Weber. It's a simple addition, so you can do it. 249.8 plus 159.2. By adding this two term, we get 409 into 10 raised to 4 ampere turn per Weber. It is a total reluctance. So now I have to find out the current passing through the coil. So we know that total mmf required to flow is current is mmf equal to flux into reluctance. Flux into reluctance. So mmf is given by I into A, flux is given by 5 and reluctance is given by S. So equation become IN equal to 5 into S. So put the value of all the term, put the value of current, we have to find out value of turn is 1200 equal to 5 is a flux is given into the data 0.5 milliweber, so it's a 10 raised to minus 3, and we have find out the value of S 409 into 10 raised to 4. Now I equal to 0.5 into 409. By solving this 2 we get 10 and denominator 1200, and by solving we get the current 1.704 ampere. It's a simple division. Multiply these three terms and divide by 1200. We get the value of current is 1.704 ampere. So it's a simple equation, but what we have to did, first reading data, then we have to take the list which terms are given. So here we have to first make the list given data, then we find out the mean length of iron core. After this iron core, we go for the reluctance, and we have find out the reluctance of air gap. So first find out the reluctance of iron Si, then find out the reluctance of air gap Sa, then total reluctance S equal to Si plus Sa. When we find the total reluctance, go for the equation of MMF. MMF equal to flux into reluctance, In equal to phi into S. Now put the three value, we get the answer of L. So I is 1.704 into A. So this way we can find out the value of current. Okay, now next question. Define the following terms: cycle, time period, power factor, form factor, frequency, phase difference and phase sequence. Simple 7 definition gives 7 marks. So we have to explain every definition, and we also give the some equation and if have any relation. See, cycle, the one complete set of positive and negative value of an alternative quantity is known as cycle. As shown in the figure, one complete set of positive value and negative value is known as cycle. Now again, cycle is defined by the another term. It's called this dotted line called maximum value in positive side, and dotted value in negative side gives maximum value. So different definition of the cycle is if any value, current or voltage, rise from 0 to maximum and decrease and become 0, again increase in negative direction and become maximum, and again becomes 0. This complete process is known as a one cycle. So is in figure, the sine wave shown is one cycle. Second, an important definition is time period. The time taken by the alternating quantity to complete one cycle is known as time period. If one cycle is completed into 1 second, then it's called time period of 1 second. If it is completed into 2 seconds, then it is called time period of 2 seconds. Similarly, whatever the time required by complete one cycle is known as a time period. It defined by or denoted by capital T, and unit is a second. It may be a millisecond or a microsecond, but basic unit is second. Third, an important definition is frequency. It is important. The number of cycles per second is known as the frequency. How many number of cycles per second? Now it is important. In a 1 second, how many cycles are passes of alternating quantity, that is called frequency. If 50 cycles are passing into the 1 second, then frequency is known as a 50, but frequency has unit hertz, so we can say that it is a 50 hertz. If someone said that frequency is 25 hertz, then in a 1 second only 25 cycles are passing. Okay, so that is called frequency, number of cycles per second, and unit is a hertz. It is denoted by small f. Power factor. Important definition of power factor. The cosine of the phase angle between the supply voltage applied to the circuit and current flow through the circuit is known as the power factor. Power factor is denoted by cos phi. What is power factor? It is a cosine angle of, or we can say phase angle between voltage and current. Simple. See in the projector. Suppose supply voltage is V and passing current is I, shown by the vector diagram. Then it forms some angle between it. So this angle is phi, and if solve this circuit, we get the angle cos. We find the cosine of this angle. Then this cosine is known as a cos phi. The angle between voltage and current is known as a power factor. Form factor. The ratio of RMS value to the average value is known as form factor. So in simple equation form, we can write down the form factor equal to RMS value upon average value equal to 1.11. Because value of RMS is fixed, value of average is fixed. So by taking the ratio RMS value and average value, we get the value is 1.11. It is a fixed value of a form factor. Third and important is phase difference. The phase difference or phase angle of alternating quantity may be defined as the angle of lag or lead with respect to the reference axis or reference wave. So what is difference? Difference, that means it may be a lagging or it may be a leading. We take one reference axis. As a reference, we take either voltage or either current, and then with respect to voltage or with respect to current, second signal is lagging or leading by some phase angle, that is called phase difference. See in this figure, one waveform is represented by the red color and second is represented by the blue color. So there is a phase difference between these two signal is given by theta. So it is either lagging or leading, but there is a difference phase angle between two waves.